Wingsuiters ready for action. Down into the valley without propulsion. At more than 200 kilometers an hour, as close to the rock face as possible. Total trust in gravity, the suit, and last but not least, the parachute. The flight continues even after landing. Wingsuiters like to capture their kick on camera. The latest video is on the web in no time. But here, extra power is necessary. Action videos, music files, data transfer on the web requires a tremendous amount of power for ventilators, processors, and hard drives. Greenpeace estimates that around 2% of globally produced electrical energy is used to transport data on the web. That equals the electricity production of more than 30 nuclear power plants. The problem is, data flows and energy demands keep increasing. One of the IT sector's most important tasks in the coming years, more efficient servers. That's why scientists and engineers at a Munich semiconductor company are working with several German universities to decrease the energy needs of server farms. They're also trying to reduce the amount of heat dissipation generated by individual components. In many cases, a server may require more energy for cooling than for actual data transfer. To lower the overall power requirements, scientists are researching a new kind of material in a special laboratory in the Austrian city of Villach. Silicon carbide. This new semiconductor is transparent and could replace the silicon used until now. The new microchips are designed to use less electricity.
Due to special physical properties of silicon carbide, we can use much higher dopings, and therefore outstanding electrical conductivity can be reached.
The silicon used until now to make microchips has a very definite structure. Countless atoms are bound together in a grid. The grid occasionally contains foreign atoms that possess a free electron. The new silicon carbide material, on the other hand, has a totally different structure. One half is made of silicon, and the other half is made up of carbon atoms. The result is a stronger binding of the individual atoms in the grid. That means the grid can contain more foreign atoms with free electrons. The higher number of free charges allows the silicon carbide to conduct electricity better than the silicon used until now. And the higher conductivity of the chips automatically leads to less heat dissipation in the server. The engineers subject silicon carbide to a test. The goal is to measure the concrete energy consumption. The module with the new material is installed in the server on the left side of the hall. A special measuring device captures the amount of power use down to a single watt. The server on the other side is likewise provided with a measurement device and with the conventional silicon technology. The same amount of data flows through both servers, more than 160 gigabits per second. Each server uses just over 40 kilowatts. The experiment runs for several hours. Data from the two servers are continuously compared. The result? The server with the more electrically conductive silicon carbide uses considerably less power.
It's not only about less energy consumption in server itself, but due to higher efficiency which we reach in the system, it will be less heat production, and therefore we need less energy for air conditioning.
Less power consumption in the individual components means less energy for the air conditioning. If server farms would use more of the new material, they could save the amount of energy produced by one nuclear power plant and put the brakes on the rapid growth of electricity needed for information technology. These daredevil jumps cause more than just a thrill in the air. They can also pull off an efficient landing on the World Wide Web.